Okay, question number 7. Chloroethane CH3CH2Cl and ethanoyl chloride CH3COCl will both react with water. The mechanism of both reactions is nucleophilic substitution. Okay, explain the mechanism of the reaction between chloroethane and water. Okay, you should use a curl arrow to show the movement of electron pair, label any relevant dipoles, show any relevant lone pairs of electrons, include the formula of the final product. So 4 things you should do and 4 marks. Okay, so here we have chloroethane, CH3, so structural formula, this will be better, CH2 and Cl. Okay, CH3, CH2, Cl, and we have here water molecule, so HOH. Okay, so in oxygen we have 2 lone pairs. Okay, use curl to show the movement of electron pair, any relevant dipoles. So here we have partial positive, partial negative, because chlorine is more electronegative, and this lone pair attacks this carbon. Okay, please indicate that the lone pair or electron pair is attacking the carbon. Okay, clearly. So then carbon cannot have 5 bonds at one time. So what will happen to this bond? This bond breaks, so electron pair of this bond goes to chlorine, and we will form CH3, CH2, OH, H with positive sign. Okay, and what's next? Just this bond electron pair comes back to oxygen, and you get in this case ethanoyl, CH3, CH2, OH. So hydrogen from here you can write as HCl. So we have a hydrogen, here we have chloride, so hydrogen chloride. So lone pairs of electrons, here lone pairs, we showed dipole and movement of electron arrows, include formula of the final product is CH3CH2OH. Okay, very easy, 4 points. Next, if aqueous silver nitrate, silver nitrate is added to chloroethane, a white precipitate forms very slowly. If aqueous silver nitrate is added to ethanoyl chloride, a white precipitate forms immediately. Name the substance seen as a white precipitate. So both of them has chlorine atom. So argentum, silver nitrate forms white precipitate, which is silver chloride. White precipitate. And the reason why ethanoyl chloride is more reactive than chloroethane, because in ethanoyl chloride, from the structure we can see that CH3CO chloride, so CH3, C, double bond O, and chlorine. So let me use different marker. So it's partial positive, partial negative, this is partial positive, and also we have chlorine, which is also will have partial negative, because chlorine is also more electronegative than carbon. So this makes the carbon to become very partially positive, okay, which easily attracts nucleophile. Okay, very partially positive. The bond, so here also will break easily between carbon and chlorine. Next question. Alkyl halides can be formed when alkenes react with hydrogen halides. Take an example of ethylene. Draw the mechanism for the addition reaction with the hydrogen bromide. So here we have ethylene, hydrogen, 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 and hydrogen. We need to react with hydrogen halide. So we use hydrogen bromide, hydrogen bromide. So this, in this case, don't forget about dipole. So this is partial positive, this is partial negative, and electron rich area of the double bond attacks hydrogen because it's partial positive, and this bond breaks. Okay, and you will form hydrogen, carbon, hydrogen. If hydrogen goes to the first carbon and double bond breaks, form single bond. Here we have hydrogen, hydrogen, and we are forming carbocation. And in the solution we have bromide ion with lone pair. So next, this lone pair attacks positive carbon, and we will form just hydrogen, carbon, hydrogen, hydrogen, C, hydrogen, hydrogen, and bromide. Okay, so 4 marks, I think, in this case, for the dipole moment. So here we have partial positive, partial negative, 1 mark, and clearly arrow showing that double bonds are taking the partial positive hydrogen, and we are forming carbocation and the product. Here product is bromethane. So okay, bromethane we don't need to name. This is structure, and name the mechanism in CI. So it is addition and involves electrophile. So this is electrophilic addition. So yeah, so please revise the mechanisms. So there are a lot of mechanisms. So mechanisms are very important in organic synthesis.